You know that feeling when you hit order on a grocery app and what feels like seconds later a rider is at your door? It seems like actual magic, but it's not magic, it's code. Incredibly complex, ridiculously fast code. Today we're going to pull back the curtain on the technical design that makes instant commerce a reality. All right, let's get into it.
This right here, this is the promise. The entire business model lives or dies by this number. Getting your groceries from a warehouse to your couch in less time than it takes to watch a TV show. I mean, think about that. Pulling this off isn't just a delivery problem. It's a massive, massive engineering challenge.
So really, how do they do it? How does the system juggle thousands of products, hundreds of riders, and tens of thousands of customers all at the same time without just collapsing? Well, the secret sauce is in the architecture, the digital blueprint that's engineered for one thing and one thing only: pure, unadulterated speed.
To really understand the solution, we first have to get our heads around the sheer scale of the problem. So let's break down exactly what this system needs to handle every single second to make that 10-minute promise actually happen.
Just look at these requirements. It's kinda wild. The system has to work in these tiny 2 to 3 kilometer zones, which means it needs a perfect real-time picture of inventory. But here's the kicker. It has to handle over 100,000 people using the app at once and process 50,000 orders an hour, all while being up 99.9% of the time. That means the system can only be down for a few minutes a month. The margin for error is practically non-existent.
So, how on earth do you build something that can take that kind of pressure? Well, you don't build one giant clunky program. You build a team of specialists. Let's take a look at how this blueprint for speed is actually put together.
I love this analogy. Think of a huge, super busy, high-end kitchen. You don't have one chef trying to do everything, right? No way. You've got a sauce chef, a grill master, a pastry expert. Each one is a master of their specific domain. The tech behind this whole thing? It works exactly like that.
And this team of chefs approach has a technical name. It's called a microservices architecture. Instead of one giant app, the system is broken up into a bunch of smaller, independent services. Each one has a single job, and they all communicate with each other. And here's the genius part. If the pastry station has a problem, it doesn't shut down the entire kitchen.
And here are the star players in our digital kitchen. You've got the user service, which only cares about who you are. The catalog service, which just manages the products. The inventory service is completely obsessed with one thing: knowing what's in stock. Each one is a tiny expert, which makes the whole system incredibly efficient and, importantly, resilient. Okay, so before you even tap Add to Cart, two of the most important parts of the system are already working like crazy. These are the services that manage the products and make sure what you see on the app is actually on the shelf. Welcome to the digital stockroom. Now, to manage all this data, the system has two different kinds of memory. Think of Postgres as the long-term memory. It's like the company's official library, reliably storing permanent records like your account info and order history. But then you have Redis. That's the short-term, super fast memory. It holds what's happening right now: your shopping cart, livestock counts. You absolutely need both, one for rock-solid reliability and one for pure, mind-bending speed.
All right, the moment of truth. You filled your cart, you're ready to go. The second you tap that place order button, a high-speed digital race against the clock kicks off. And this is by far the most time-critical part of the whole operation.
And what's the goal for this entire automated sequence? Under 2 minutes. Yep. From your tap on the screen to a rider being assigned and your order getting packed, the system has less than 120 seconds to pull off a super complex chain of events, and it has to do it perfectly. It's like a digital ballet of incredible precision. And this shows you that ballet in action. The instant your order is placed, boom, the system reserves those items so nobody else can grab them. Once your payment clears, the stock count is officially reduced. Then, an algorithm finds the best rider, and as soon as the order is out the door, your live tracking map springs to life. Each step is an automated event that triggers the next one in milliseconds. So behind the scenes, every single order looks something like this: a neat little row in a giant database. This is the system's single source of truth. It gets a unique ID, it's tied to your user account, and its status, pending, packing, dispatched, gets updated in real time at every single step of that life cycle we just saw.
So you ever wonder how you can actually see that little bike icon moving on the map in real time? That's powered by a really cool technology called WebSockets. Instead of your phone constantly bugging the server, "Where's the rider now? How about now?" a WebSocket opens a direct, two-way line of communication. The moment the server gets an update, it pushes it directly to your phone. No delay, it's instant.
Okay, so the system is fast. We get it. But what happens when it's not just you ordering, but thousands of people all at once during that Friday night pizza and ice cream rush? Well, this is where the real magic of the system kicks in. Its ability to scale on demand.
So on a typical Tuesday afternoon, the system is probably just cruising along, looking something like this. Each of our specialist services, like the order service, might have maybe 3 active servers, what they call pods, easily handling the flow of requests. It's super efficient, no wasted energy.
But then the Friday night rush hits. The system detects this huge surge and automatically, and I mean instantly, does this. It just spins up more servers for the services that are getting hammered. Suddenly, the order service might have 20 servers handling that flood of new purchases. This is called horizontal scaling. It's like instantly hiring 17 more chefs just for the dinner rush and then sending them home when things quiet down. It's brilliant.
And this quote from the actual design document just sums it all up perfectly. The entire system is built not just to survive high traffic, but to do it efficiently. It grows and shrinks exactly when it needs to, which keeps the service fast without costing a fortune in servers that are just sitting around.
So when you put it all together, the specialized services, the dual memory databases, the event-driven lifecycle, and that incredible elastic scaling, you really start to see the full blueprint. This is the code for instant commerce.
It all boils down to these fundamental principles: scalability to handle any rush you throw at it, performance, using smart tricks like caching so the system isn't doing the same work over and over, reliability, so one little bug can't bring the whole house down, and of course, real-time features that give us that instant feedback we all expect now. That's the recipe.
And here's the biggest takeaway. This architecture is everywhere. When you call a rideshare, when you order from a food delivery app, when you play a massive online video game, you are interacting with a system built on these exact same principles of microservices, real-time data, and massive scalability. The 10-minute delivery is just one amazing example of what this blueprint can achieve. So you have to wonder, what's next?